everybody! Today I am going to talk to you about numbers and counting and maybe even spaghetti. Oh, I love spaghetti. Okay, so one thing we use numbers for is when we are counting. And we can count using our voice. Voice! Let's try it. I want everybody to count and say the numbers from 1 to 10 out loud using your voice. Use your voice! Okay, ready? Go! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ha ha! Good job! But did you know we can also write numbers? No, it's true! We call them numerals. Numerals! For example, the number 1 looks like this, and you can write it like this. And the number 2 looks like this, and you can write it like this. So let us count again to 10 using our voices and watching how we write the numbers. Okay, ready? Go! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow! You did such a good job. I think it may be time to celebrate. Yay! Okay, that's enough. So, we can say numbers and we can write numbers, but did you know we can also use numbers to count actual things we see every day? Oh, yes, we can. Let us use an example. Oh, what should we use? Hey, I know. How about spaghetti? Spaghetti! Wow, that is a big meatball. Okay, so if I ask you, how many plates of spaghetti do you see? What would you say? That's right. There is 1 plate of spaghetti. We can say the 1. We can write the 1. And there is actually 1 plate of spaghetti. See? 1. Now, how many plates of spaghetti do you see? That's right. There are 2 plates of spaghetti. We can say 2. 2. This is how we write 2. And there are 1, 2 plates of spaghetti. So now let's count to 10 again together while watching the plates of spaghetti. Okay, ready? Go! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, great. I think you really like spaghetti. Now, let's count something else. How about the letter X? I said letter X! Say hi to the letter X. How many letter X's do you see? There are, let's count. 1, 2, 3, 4, 5. There are 5 letter X's. We can say 5. 5! And we can write 5. And we know from counting them, there are actually 5 letter X's. See? 1, 2, 3, 4, 5. So even if the X's go all the way over there, there are still 5. 1, 2, 3, 4, 5. And even if they are spread out, there are still 5. 1, 2, 3, 4, 5. Even if they are upside down, there are still 5. 1, 2, 3, 4, 5. Even if they are upside down, purple with green polka dots and all with mustaches, there are still 5. 1, 2, 3, 4, 5. Ho ho! Good job counting. I think it may be time to celebrate. Yay! Okay, that's enough. Now, let's find something else to count. Hey, do you know what this is?
Is it a plate of spaghetti?
No, it is a calendar.
That's what I said, a calendar.
No, you did not. Anyway, a calendar shows you all the days and all the weeks of a month. Let us look at just 1 week and try and count the days. Do you know how many days there are in 1 week? 7! let us count how many days there are in a week together. Ready? Go! 1, 2, 3, 4, 5, 6, 7. Wow, you did so great that I think it may be time to celebrate! Yeah! Okay, that's enough. Oh, hi, everybody! Today, I'm going to talk to you about numbers, and counting, and estimating, and maybe even bananas. I really like bananas. Okay, so one thing we use numbers for is when we are counting. And sometimes when we are counting, and especially when we have to count something quickly, we use estimating. Estimating! Estimating is kind of like guessing. You all know what guessing is, right? Let's try. Right now, I want you to guess what is behind me. I will give you a hint. It is a fruit, and it is long and yellow. Can you guess? That's right! It's a banana! Yay! Because you did such a good job, it is now time for a break. Okay, that's enough. So, when we want to guess something that is about the numbers, we call it estimating. Estimating! In a minute, I am going to show you some more bananas. Bananas! And you are going to guess or estimate how many bananas there are. Bananas! You already said that. But first, let us make sure we all know the numbers from 1 to 10. Let's all count to 10 out loud together. Okay, ready? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ha! Good job! So, these are all the numbers or numerals from 1 to 10. And did you know that we can also show numbers using bananas? Oh, yes we can! For example, this is what 2 bananas look like. This is what 5 bananas look like. And this is what 10 bananas look like. I will show you again. This is what 2 bananas look like. 1, 2. This is what 5 bananas look like. 1, 2, 3, 4, 5. And this is what 10 bananas look like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, I am going to quickly show you some different bananas, and I want you to estimate how many bananas you think there are. And remember, because you are estimating or guessing, it is okay if you don't know the exact number of bananas. Are you ready to see some bananas? Of course you are! Yay! Here we go. Okay, that was a pineapple, not a banana.
Who put that pineapple in there?
I did! Sorry! Okay, let's try again. Ready? Here we go. So, what was your estimate of how many bananas there were? Let's count and find out. Bananas! I said bananas! 1, 2, 3 bananas. Remember, 2 bananas look like this, so if we add 1 more, we know that 2 plus 1 is 3. 3 bananas! Bananas! Okay, you did such a good job. Let's take a quick break. Okay, that's enough! Now, let us do some estimating again with a different number of bananas. Ready? Here we go. So, what was your estimate of how many bananas there were? Let's count and find out. 1, 2, 3, 4, 5, 6 bananas. Remember that 5 bananas look like this. So, if we add 1 more, we know that 5 plus 1 is 6. 6 bananas. Bananas! If you estimated that there were 6 bananas, good job! If you estimated that there were 5 bananas, also good job! Because 5 is close to 6. Want to know something? Of course you do! 6 bananas don't always look exactly like this. They could look like this, and there would still be 6. They could also look like this, and there would still be 6. They could also even all have funny hats, and there would still be 6. Okay, let us do some estimating one last time with a different number of bananas. Ready? Here we go. So, what was your estimate of how many bananas there were? Let's count to find out. 1, 2, 3, 4, 5, 6, 7, 8 bananas. Remember that 5 bananas look like this. So if we add 3 more, we know that 5 plus 3 is 8. 8 bananas. Bananas! But maybe you estimated a different number, and that's okay. For example, remember that 10 bananas look like this. So if you take away 2 bananas, we know that 10 minus 2 is 8. 8 bananas. Bananas! If you estimated that there were 8 bananas, good job! If you estimated that there were 5 or 10 bananas, also good job, because 5 is kind of close to 8, and 10 is also close to 8 too. If you estimated that there were 100 bajillion triple bananas, that is not so good, because that is not even a real number. Okay, that is all the time we have today for estimating. Hi, everybody! Today, I'm going to talk to you about numbers, and composing and decomposing numbers, and maybe even apples. I really like apples. So, composing is a large word. Composing! And it's what happens when little numbers come together to make a bigger number. And decomposing is an even larger word. Decomposing! And that is what happens when a bigger number is taken apart into little numbers. And there are many, many, many different ways to put numbers together and take them apart. I will show you with an example. Here we have the number 2, and there is another number 2. What happens if you put 2 and 2 together? That's right, you get 4. 4! This 2 and this 2 came together and made the number 4. So 4 is made up of 2 and 2, which means 4 can be taken apart into 2 and 2. Wow! We can put together and take apart the number 4 with totally different numbers. No, it's true. Watch. Here we have the number 3, and there we have the number 1. What happens if you put 3 and 1 together? That's right, you get 4. 4! The 3 and the 1 came together and made the number 4. So 4 is made up of 3 and 1, which means that 4 can be taken apart into 3 and 1. Wow! So there are at least 2 different ways to put together and to take apart the number 4. Okay, you are doing such a good job listening, you can now watch a movie. Okay, that's enough! This may be easier to explain if we have something to help us. I know, apples! I said apples! Okay, look, we have 1, 2, 3, 4 apples. And we can take them apart, or they can move, so we have 2 apples here and 2 apples there. But we still have 4 apples. And what happens if 1 apple moves? Well, then we have 1 apple here and 3 apples there. But we still have 4 apples. Apples! Okay, let us start again with some more apples. Now we have 1, 2, 3, 4, 5, 6, 7 apples. Apples! Let's see how we can take apart and put together these 7 apples. Maybe we should use something to help us organize them. Oh, I know. How about funny hats? Ha! Now, let's have all of the apples with yellow hats go over here, and all of the apples with green hats go over there. So now we have 1, 2, 3 apples with yellow hats and 1, 2, 3, 4 apples with green hats. Add them together and we have 7 apples. So, the numbers 3 and 4 make the number 7. 7! Now, let's have all of the apples with little hats go here, and all of the apples with big hats go over there. So now we have 1, 2, 3, 4, 5 apples with little hats, and 1, 2 apples with big hats. Add them together, and we have 7 apples. So the numbers 5 and 2 also make the number 7. Wow! 7! Okay, one more. How about all the apples that have a bite out of them go over here, and all of the... What's that? None of the apples have a bite? Oh, well, we have to fix that. As I was saying, all of the apples with the bites go over here, and all of the apples without bites go over there. So now we have 1 apple with a bite, and 1, 2, 3, 4, 5, 6 apples with no bites. Add them together, and we have 7 apples. So the numbers 1 and 6 also make the number 7. 7! Okay, let's take a break and watch a movie. Okay, that's enough. Last one with even more apples, but this time, no funny hats. Wow, so many apples. How many? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 apples. And there are many, many, many ways to compose or put together 16 apples, and also to decompose or take apart the 16 apples. Let's try some. Sometimes when we are thinking about numbers, it can be easier to think about the numbers 10 and 5. So if 10 apples go here and 5 apples go there, how many apples do we have left? That's right, 1. 10 plus 5 plus 1 is 16. So the number 16 can be made up of the numbers 10 and 5 and 1. Cool! Let's try again, apples. Move! Oh, wow. Now we have 1, 2, 3, 4, 5, 6, 7, 8 apples over here, and the same number of apples over there. 8 plus 8 is 16. So the number 16 can also be made up of the numbers 8 and 8. Okay, one last time. Move, apples! Oh, cool! Now we have 1, 2, 3, 4 apples here, and the same number 4 apples here, and the same number 4 apples here, and the same number 4 apples here. 4 groups of 4. 4 plus 4 plus 4 plus 4 is 16. So the number 16 can also be made up of the numbers 4, 4, 4, and 4. And guess what? You can also make up and take apart the number 16 with other numbers that we haven't even practiced yet. No, it's true. Okay, that is all the time we have today for composing and decomposing. Oh, hi, everybody! Today, I'm going to talk to you about numbers, and adding and subtracting numbers, and maybe even donuts. Huh, I really like donuts. So, we all know that numbers can be joined together to make bigger numbers. We call this adding. Adding! And we also know that we can take away numbers from bigger numbers to make smaller numbers. We call this subtracting. Subtracting! Let us use an example. We need a volunteer. How about sloth? It says sloth. Okay, here is a sloth. And we see that sloth has 2 donuts. 1, 2. What happens if we add 1, 2, 3 more donuts? Yes, that's right. Sloth gets happier. But also, mathematically, if we add 2 and 3 together, we get 5. 5 donuts. Now what happens if we subtract 1, 2, 3, 4 donuts from sloth? Yes, that's right. Sloth gets sadder. But also, mathematically, if we have 5 and we subtract 4, we only have 1 left. 1 donut. Wow, you did such a good job adding and subtracting. It's now playtime. Okay, that's enough. So, we can add and subtract with donuts, but did you know that we can also add and subtract with writing? No, it's true. We can do it by writing the numbers or numerals and also by writing with signs. This is a plus sign.
Plus sign.
This is a minus sign.
Minus sign.
And this is an equal sign.
Equal sign.
And this is a monkey riding a unicycle sign. But we never use that one in math. Please go away, monkey riding a unicycle sign. Okay, great. So, let's add and subtract the same number of donuts with sloth, but this time also write the numbers and the signs. Ready? Of course you are! Sloth? Sloth! Finally. First, the adding. 2 donuts plus 3 donuts equals 5 donuts. 2 plus 3 equals 5. 2 plus sign, 3 equal sign, 5. Happy sloth. Now, subtracting. 5 donuts minus 4 donuts equals 1 donut. 5 minus 4 equals 1. 5 minus sign, 4 equal sign, 1. Sad sloth. Okay, let's do another one, but with some different numbers and different donuts. Oh, purple. So, let's see. We have 1, 2, 3, 4 donuts, and we add 1, 2, 3, 4, 5 donuts. So we have, anybody know? That's right, 9 donuts. 4 plus 5 equals 9. 4 plus sign, 5 equals sign, 9. Super happy sloth! So I have a question. What do you think happens if we switch the 4 and the 5 like this? Now how many donuts do we have? That's right, the same number of donuts. 9 donuts! So, 4 plus 5 equals 9. And 5 plus 4 also equals 9. 4 plus 5 equals 9. And 5 plus 4 equals 9. Everybody, 4 plus 5 equals 9. And 5 plus 4 equals 9. Happy sloth. 4 plus 5 equals 9. And 5 plus 4 equals 9. Okay, that's enough. Hey, want to know something? Of course you do. The plus sign and the minus sign are kind of like opposites. You know, opposites. Just like happy and sad, big and small, and daytime and nighttime. Opposites.
Opposites.
And we can use the plus sign and the minus sign in opposite ways with the same numbers to check if our math is correct. No, really, watch. If 5 plus 4 is equal to 9, then 9 minus 4 is equal to 5. Same numbers, different order, and different signs, but both are correct. 5 plus 4 equals 9. Correct. 9 minus 4 equals 5. Correct. 5 plus 4 equals 9. Correct. 9 minus 4 equals 5. Correct. 5 plus 4 equals 9. Correct. 9 minus 4 equals 5. Correct. Okay, that's enough. Okay, let's do one last example of adding, but with some different numbers and different donuts. Whoa, sprinkles. Wow. So, this one may be a little tricky. We have 1, 2, 3 donuts, and we add no more donuts. So now we have, anybody know? That's right, 3 donuts. Do you know what is the number we use when we don't have anything? That's right, 0.
0!
Yeah, so that means 3 plus 0 equals 3. And what if we had 4 donuts and we added 0? That's right, 4 plus 0 equals 4. And so even if you had a really, really, really high number of donuts, like 17, and added 0, you would still have 17 donuts. Yay! Okay, you did such a good job adding 0. It is now playtime. Okay, that's enough. That is all the time we have today for adding and subtracting. Oh, hi, everybody! Today, I'm going to talk to you about numbers and fractions and maybe even Kevin. Huh, I really like Kevin. Okay, so we all know how to count things, right? Yes, of course you do. But do you know how to count parts of things? I will show you. First, we need something that we can count and also divide into equal parts. How about a pizza? Oh, no, not another pizza example. We need something else. How about me? Oh, good idea. Okay, so now, how many me's do you see? That's right. There are 1, 2, 3 me's. And now, how many me's do you see? Yes, there is just 1 me. 1 whole me. Yay! But now, watch closely, but don't worry, I am a cartoon, so it won't hurt. How many me's do you see? Are there 2 me's? No, not really. There are 2 parts of me, or 2 equal halves of me. 1 half here and 1 half here. And when we put 1 half and 1 half together, there is 1 whole me. So, in math, when we have parts of whole things like this, we can call these parts fractions. Fractions! Okay, you did such a good job listening. It is now time to sing a song. Okay, that's enough. So as I just showed you, if I divide myself into 2 equal parts, then I have 2 halves. But what happens if these halves also get divided into halves? Okay, watch. And don't worry, I am a cartoon, so it won't hurt. So now, are there 4 of me? No, not really, but there are 4 equal parts of me. So we can call them fourths. Fourths! 1/4 here, 1/4 here, 1/4 here, and 1/4 here. We can also call a fourth a different word, and that word is quarter. Quarter! So, 1/4 here, 1/4 here, 1/4 here, and 1/4 here. And if we put 4 quarters or 4 fourths of me together, there is 1 whole me. Okay, let's review because it might be a little confusing. Uh-oh, where did I go? Don't worry. So, this is 1/4 of me, or 1/4. This is 2/4 of me, or 2/4. And 2/4 is also the same as 1/2. 1/2. This is 3/4 of me, or 3/4. And this is 4/4 of me, or 4/4. And 4/4 is the same as 1 whole. 1 whole! Phew! You did such a good job listening. It is now time to sing a song. Okay, that's enough. Let's talk about something else besides me. Do you know when is another good time to use fractions? When we are sharing something, especially if we want to share something fairly and give everybody the same amount. Let's use something to help us explain. What can we use? Oh, I know. How about Kevin? I said Kevin! No, I want all the Kevins. Okay, here we have 4 Kevins. Kevin, Extra Kevin, Secret Kevin, and Funnest Kevin. What if we have 8 cookies and we want to share these cookies fairly to all the Kevins? Let's try. Move, cookies. Okay, now each Kevin has the same number. 1, 2 cookies. Come back, cookies. Now what happens if 2 of these cookies disappear? Well, that means we only have 6 cookies left. Let's try and share them. Now each Kevin has 1 cookie, but there are 2 cookies left. How can we share them fairly? It looks like we're going to have to make some fractions and break the cookies in half. Now each Kevin has 1 cookie and 1/2 of a cookie. 1 and 1/2 cookies each. Okay, come back, cookies. Okay, now what happens if 5 more of the cookies disappear? Well, that means we only have 1 cookie left. Let's try and share them. Hey, how can we share 1 cookie fairly? It looks like we're going to have to make some fractions and break the cookie into quarters. Now, each Kevin has 1/4 or 1/4 of a cookie. Don't be sad, Kevins. You got 1/4 of a cookie. Okay, that is all the time today we have for fractions. Oh, hi, everybody. Today, I'm going to talk to you about numbers and measuring and maybe even salamanders. I really like salamanders. So, one thing we use numbers for is when we are measuring. Measuring is finding out the size of something or the amount of something. And we can measure many things like time, weight, temperature, or even speed. But today, we are going to measure length. Length is the distance between 2 points, like how far it is between the start and the end of something. And we measure length to find out how long something is, and also how tall, or wide, or even how far away something is. Okay, this might be a little confusing, so why don't we take a break and have a snack? Hum. Okay, that's enough. Anyway, when we measure the length of something, we measure with units. There are many standard units that you can use, like inches or centimeters. There are also many non-standard units that you can use, like paper clips. Today, I want to use my favorite non-standard unit, the salamander. It's a salamander! So, right now, salamander is going to be a unit that we can count and use to measure things. But before we do that, we need to talk about the rules for measuring, which leads us to a new segment called
The Important Rules for Measuring Length in Straight Lines with Non-Standard Units.
Wow, that is a long title. Rule number 1. All of the units need to be the same size and direction. Sorry, super tiny salamander. Sorry, turtle. Rule number 2. All of the units should touch each other at the ends, but not overlap on top of each other. And they should also not be spread out. Salamanders, come back! Rule number 3. Usually, the units need to make a straight line. Like this. But not like this. And rule number 4. When measuring something, for example, the length of this book, we start the units next to one end of the book and finish at the other end of the book. Like this. So we don't start from the center of the book, and we don't start from over here or in some other place like the beach. Okay, that now ends the part of the show called
The Important Rules for Measuring Length in Straight Lines with Non-Standard Units.
Okay, so now let's do some measuring. First, we need something to measure. What should we use? Oh, I know. How about cows? With funny hats. Ha! Okay, here we have 3 cows. Blue cow, red cow, and yellow cow. And they all have funny hats. But I want to know which cow has the tallest hat. So we will have to measure the length, or some might call it the height, of each cow's hat. And first up is blue cow. Let's measure the height of blue cow's hat with salamanders. Remember, we start measuring at one end of the hat and go in a straight line next to the hat all the way to the other end of the hat. So, blue cow's hat is 1, 2 salamanders long, or we can also say 2 salamanders high. Okay, red cow. Red cow's hat is 1, 2, 3, 4 salamanders long, or we can also say 4 salamanders high. And last is yellow cow. Yellow cow's hat is 1, 2, 3, 4, 5 salamanders long, or we can also say 5 salamanders high. Now, let's compare hats. But first, snack time. Hum, hum. Okay, that's enough. So, blue cow's hat is 2 salamanders high. And red cow's hat is 4 salamanders high. 4 is a larger number than 2. So that means that red cow's hat is taller than blue cow's hat. And the opposite is also true. Blue cow's hat is shorter than red cow's hat. Now, if we look at yellow cow's hat, it is 5 salamanders high. 5 is a larger number than 4, so this means that yellow cow's hat is taller than red cow's hat. And the opposite is also true. Red cow's hat is shorter than yellow cow's hat. And 5 is also a larger number than 2, which means that out of all of the cow's hats that you can see right now, yellow cow's hat is the tallest. Hat. Taller hat. Tallest hat! Yay! Okay, good job. Now that you're getting better, let's measure how wide each of the cow's hats are. We call this the width. Width! And instead of measuring up, we will measure from side to side, from left to right. Ready? Let's go! So, how many salamanders wide is blue cow's hat? And how many salamanders wide is red cow's hat? And finally, how many salamanders wide is yellow cow's hat? So, which cow has the widest hat? Okay, that is all the time today we have for measuring. And remember that you can measure things too, like right after this video is over, And even if you don't know any cows with funny hats. And if you don't have any salamanders to measure with, you can use other things like rulers or erasers or even your feet. I wish I had feet. Anyway. Oh, hi, everybody. Today, I'm going to talk to you about patterns. And patterns. And maybe even patterns. I really like patterns. Okay, so a pattern is something that happens again and again. And when something happens again and again, we say that it repeats. Repeats. Boop. Repeats. Boop. Repeats. Boop. Okay, that was a pattern that was made by repeating sounds and repeating actions. But did you know we can also see patterns? Oh, yes, we can. For example, look at this beautiful sweater. Oh, wow. If you look closely, the same kind of stripes happen again and again. Red, green, yellow. Then red, green, yellow. Then red, green, yellow. And when the same things happen again and again and in the same order, it is called a pattern. And a pattern always repeats. Repeats. Boop. Okay, so let us practice some patterns together. And first, we are going to practice with our hands. Most people have two hands, a left hand and a right hand. Now let's make a pattern. When I say left, raise your left hand high. When I say right, raise your right hand high. And you can say the words with me too. Ready? Okay, go. Left, right. Left, right. Left, right. Left, right. Good job. Left and right repeat in the same order, so that was a pattern. Now, instead of saying left and right, raise the same hands, but say A and B. Ready? Okay, go. A, B. A, B. A, B. A, B. Oh, wow, good job. A and B repeat in the same order, so that was a pattern. And guess what? A pattern that has two things that repeat like that is also called an A-B pattern. Fascinating! Okay, now let's make an A-B pattern, but with colors. Red and blue. And we will also see what this pattern could look like too at the same time. Ready? Okay, go! Red, blue. Red, blue. Red, blue. Red, blue. Yay! So, let's look at this pattern. We know that it is a pattern with two things, red and blue. And we can say that this is the core of the pattern. It is not just the red that happens again and again, and it is not just the blue that happens again and again. It is the red and the blue together. And it is this red and blue core that always repeats. Repeats. Boop. Okay, you've done such a good job. It is now time for a break outside. Okay, that's enough. Now, let's make some more patterns. But this time, instead of two different things that repeat, there will be three different things that repeat. And this is sometimes called an A-B-C pattern. So let's use those letters. Now, instead of the order going left and right, it is going to go left, right, up. Let's do this together with our hands and our voices. Ready? Okay, go. A, B, C. A, B, C. A, B, C. Wow! Okay, let's do another three-thing pattern, but this time with something else. What can we use? Oh, I know. How about popcorn, unicorn, and mustache? Popcorn, unicorn, mustache. And let's also see what a popcorn, unicorn, mustache pattern would look like too. Ready? Okay, go. Popcorn, unicorn, mustache. Popcorn, unicorn, mustache. Popcorn, unicorn, mustache. Okay, good job. So, we know that this is a pattern with three things: popcorn, unicorn, mustache. And that this is the core of the pattern. And the core always repeats. Repeats. Boop. And now I have some questions. Question number 1. Here is the core of the pattern: popcorn, unicorn, mustache. So what would come next right here? That's right, it would be popcorn. Yay! And after popcorn, right here, what would come next? That's right, it would be unicorn. Yay! And after unicorn, what would come next? That's right, it would be mustache. Yay! Question number 2. What do you think would happen if the pattern keeps going? Do you think it would stay the same or be different? That's right, it would stay the same. The pattern will be the same before and after. Watch. Ah! And last question. Oh no! Some of the pattern is missing. Can you help me fill it in? So let's look just before the missing spaces. There is popcorn, unicorn, mustache. Then popcorn. So here would be what? That's right, unicorn. And let's try to figure out the last space. So there is popcorn, unicorn, mustache, popcorn, unicorn, orange juice? No, let's try again. Okay. Popcorn, unicorn, mustache. Popcorn, unicorn, a pink airplane with a funny hat? Okay, wait, no, let's try one last time. There is popcorn, unicorn, mustache. Popcorn, unicorn, mustache! Yay! Okay, you've done such a good job. It is now time for a break outside. Okay, that's enough. Okay, that is all the time today we have for patterns. Oh, hi, everybody. Today, I'm going to talk to you about shapes and attributes and maybe even rocket ships. I really like rocket ships. Okay, did you know that shapes are all around us? Ahem. I said, did you know that shapes are all around us? Shapes, come around me. Okay, that's better. So, let us practice the names of these shapes. We will start with triangle, square, circle, rectangle, pentagon, and peanut butter sandwich with a pickle on top. And shapes all have something we call attributes. Attributes! That's right, attributes. Attributes! An attribute is something about a shape or something that a shape has that makes it different or similar to another shape. For example, triangle has 3 sides. 1, 2, 3. And is blue. Attributes. A square has 4 sides the same length. 1, 2, 3, 4. And is kind of furry. Attributes. Circle, wow, what a great shape. Is kind of small, has 0 sides, and is gray. Attributes. Rectangle has 4 sides. 1, 2, 3, 4, but the sides are not all the same length. And rectangle has spots. Ha! Spots. Attributes. And pentagon has 5. Wow! 5 sides! 1, 2, 3, 4, 5. And it's pink. Attributes. And peanut butter sandwich with a pickle on top, well, is brown and green and maybe delicious? Attributes. And did you know that shapes can be sorted? Oh, yes, they can. When you sort things, you put them into different groups. For example, I want to sort all the shapes that are around me into 2 groups. I want all the shapes that are food to go to the right side over here, and all the shapes that are not food to go to the left side over here. Okay, shapes, sort! Whoa, good job! Peanut butter sandwich with a pickle on top. Since you are kind of more like food and not a shape, you shouldn't really be here. Sorry, you need to take a rocket ship out of here. A rocket ship. Oh, thank you. Okay, so now I want to sort some shapes together. But first, let's have a break and take a refreshing dip in the pool. Okay, that's enough. Let me introduce you to my new machine called the ShapeMaker 17 1/2. The ShapeMaker 17 1/2 will make some shapes for us, but I need you to help me sort them. You can tell me which side, the right side or the left side, the shape should go according to an attribute. Attribute! The first attribute is color. If the shape is red, it should go on the right side. So you can point to the right side like this. If the shape is green, it should go to the left side. So you can point to the left side like this. Okay, ShapeMaker 17 1/2, start! Wow, good job, everybody. Okay, let's sort some more shapes. This time, the attribute is number of sides. If the shape has 4 sides, it should go on the right side. And if the shape has 3 sides, it should go on the left side. Okay, ShapeMaker 17 1/2, start! Or maybe we should do the first one together. So this shape has 1, 2, 3, 4 sides, so it should go on the right side. Yay! Oh, hey! How did peanut butter sandwich with a pickle on top get there? Oh, rocket ship. Thank you. Wow, everybody doing great. So now, let's sort some more shapes one last time. But first, let's have a break and take a refreshing dip in the pool. Backstroke, front crawl. Okay, that's enough. Did you know that you can sort by more than one attribute? Oh, yes, you can. This time, the attributes are size and spots. So, if the shape is big and has spots, it should go on the right side. And if the shape is small or doesn't have spots, it should go on the left side. Remember that the shape has to be both big and have spots to go on the right side. Okay, ShapeMaker 17 1/2, start! Oh, wait, what is this? Oh, I know! Does anybody know what this is? That's right, it's a pyramid, and it is actually a 3D shape, which we call an object. You can learn more about 3D shapes and objects later. This pyramid is big, but it doesn't have a spot. Left side! Oh, great job sorting, everybody. Okay, that is all the time today we have for sorting shapes. Oh, hi, everybody. Today, I'm going to talk to you about location and directions and maybe even tiny robots. Huh, I really like tiny robots. So, location is where something is. Location! For example, somebody told me there is a monster in this video. Oh, monster! But I can't find it, and I might need help locating it. Oh, monster! Where is the monster? What's that? Oh, really? The monster is behind me. Behind you! Hey, I know. Is there anything behind you? Why don't you look behind you, pick one thing, and tell me what it is? Okay, you can come on out, monster. Now where is the monster? That's right. The monster is beside me. You could also say the monster is to the right of me. To the right of you. Hey, I know. Is there anything beside you on the right side? Why don't you look to the right, pick one thing, and tell me what it is? Oh, now where is the monster go? Oh, hey, monster. Monster, I can't see anything. Monster! Where is the monster now? Yes, the monster is in front of me. In front of you! Can you please move, monster? I am trying to teach here. Okay, thank you. Okay, now where is the monster? Again, the monster is beside me. You can also say the monster is to the left of me. To the left of you! Hey, I know. Is there anything beside you on the left side? Why don't you look to the left, pick one thing, and tell me what it is? Hey, monster, what are you doing? Oh, look, the monster is upside down. It's still the same monster, though. Okay, upside down monster, where are you going? Oh, look, now where is the monster? The monster is on top of me. Or we can also say, the monster is above me. Above you! Oh, good, you are right side up again. And now, where is the monster? Yes, the monster is under me. Or we can also say, the monster is below me. Below you! Okay, now, the monster is above me. Oh, and now the monster is below me. And now it is above. And now it is below. Above, below, above, below. Oh! And now the monster is tired. It's okay, monster. You can take a break now. And speaking of breaks, let's all take a break under the stars. Oh, so beautiful. Okay, that's enough. So you see, all of these words like beside, above, below, and to the left of, and to the right of, these are all great words to say where something is. You know, location. Location. Okay, now let's play a game. This is a game about location and directions. Directions. Directions are ways to go. And when we give directions, we tell someone with our voice which way to go. So first, we need something to give directions to. Oh, I know. How about Tiny Robot? Ha! Hi, Tiny Robot. So, Tiny Robot will start here on this map of squares. and a tiny robot is hungry. Luckily, there is a plate of spaghetti here. We need to tell Tiny Robot how to get to the plate of spaghetti using these 4 different directions: up, down, left, and right. And we need to tell Tiny Robot the distance, or how far to go, using the number of squares. Okay, now, which direction should Tiny Robot go? Maybe we could do the first one together. I think Tiny Robot should go up 3 squares. 1, 2, 3. Yay! Good job, Tiny Robot! Now let's play again. Tiny Robot is still hungry and wants another plate of spaghetti. But this time, Tiny Robot has to watch out for monsters and cannot go on the squares with the monsters. So, what way should Tiny Robot go first? Yeah, I think Tiny Robot should go up. But how many squares? Yes, 1 square. So now, what direction and how many squares should Tiny Robot go? What's that? Okay, Tiny Robot, go right 2 squares. 1, 2. Yay! Good job, Tiny Robot! Okay, let's play one last time. And Tiny Robot is still hungry for spaghetti. Wow! This time, it is going to be more difficult because Tiny Robot has to watch out for monsters, volcanoes, and stinky socks. Oh, so stinky! Now, I need you to tell Tiny Robot where to go. Remember to say the direction and also how many squares. Okay, go. First, Tiny Robot should go which direction? Up! And how many squares? 1 square. Now, Tiny Robot should go which direction? Left! And how many squares? 1 square. And now, Tiny Robot should go which direction? Up. And how many squares? 1, 2 squares. And now, Tiny Robot should go which direction? Right. How many squares? 1, 2, 3 squares. Good job, Tiny Robot! Good job, everybody! Oh, I'm so happy you did not touch the stinky socks. So stinky! Whew! Okay, that is all the time we have today for location and directions. Oh, hi, everybody! Today, I'm going to talk to you about numbers and data and maybe even bugs. Oh, I really like bugs. So one thing we can use numbers with is data. Data! And some people call it data. Data! Anyway, data is when you collect and sort information, and you try and understand things, like facts about something. For example, here is some data about me. I have 1 mouth, 2 eyes, and 17 brothers and sisters. Oh, hi! Okay, so we can collect data and understand things in different ways. One way is to use our eyes and look. We call this observing. Observing! For example, I was... Hey, who is talking? Francis and August, please be quiet. Okay, as I was saying, I want to observe my brothers and sisters and collect data about what color they are. Do you want to help me? Okay, great. We can use a chart and write down the numbers beside the words of the color up here. First up is purple. So, how many brothers and sisters are purple? Let's count. 1, 2, 3, 4, 5, 6. 6. Hey, do you know what these are? These are tally marks.
Tally marks.
Tally marks are like a way of counting using special lines. When we count with tally marks, we make one up and down line for each number, up to 4, like this. And then when we get to 5, we make a side-to-side line through, like this. And now we know we have a group of 5. But after 5, well, then we start all over again and make a new group. So when we count up to 6, this is how we do it with tally marks. 1, 2, 3, 4, 5, and 6. Okay, moving on. The next color is green. How many brothers and sisters are green? Let's count. 1, 2, 3, 4. 4. And finally, how many brothers and sisters are blue? Let's count. 1, 2, 3, 4, 5, 6, 7. 7! Good job, everybody! We have now collected all the data about the color of my brothers and sisters. Yay! Okay, you've done such a good job, it is now time to take a stretching break. Oh, yeah. Okay, that's enough! So, we just saw that we can collect data and understand things by observing with our eyes. But did you know that we can also collect data and understand things by asking questions with our voice? Oh, yes, we can. Okay, let's ask my brothers and sisters some questions and collect their answers with tally marks. Okay, what should we ask them about? Oh, I know. Bugs. I said bugs. Okay, there are 3 different kinds of bugs here. A spider, a ladybug, and butterfly. I want to know which bug they like the best. So, we just saw that... Hey, who's talking? Oh, Francis and August, you need to separate. Please move. Okay, that's better. Now, brothers and sisters, I want you to raise your hand when I say the name of the bug that you like the best. And remember, you can only choose one bug and raise your hand one time. Okay, please raise your hand if you like spiders the best. And let's count. 1, 2, 3. So 3 brothers and sisters like spiders the best. Now, raise your hands if you like ladybugs the best. Let's count. 1, 2, 3, 4, 5. So 5 brothers and sisters like ladybugs the best. Now, raise your hand if you like butterflies the best. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 brothers and sisters like a butterfly the best. Wow! Great collecting data, everyone. Now let's take a break and do some stretching. Oh, yeah. Feels good. Okay, that's enough. Now, let us show this data in a different way. Instead of using tally marks, we will take the numbers and put them into something we call a pictograph. Pictograph! A pictograph is a way to show data with pictures. Okay, so remember, how many brothers and sisters liked spider best? That's right, 3. 1, 2, 3. And how many liked the ladybug the best? That's right, 5. 1, 2, 3, 4, 5. And how many liked the butterfly the best? That's right, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now our pictograph is complete. So, looking at the pictograph data, which bug do most of my brothers and sisters like the best? That's right, it's a butterfly! Yay! There are more butterfly pictures than anything else, so we have learned that among my brothers and sisters, the most popular bug is the butterfly. And which bug is the second most popular bug? That's right, it's a ladybug! Yay! Oh, here's a question. How many more ladybugs would we need to have in order to equal the amount of butterflies? If you said 4, you are right. Yay! And finally, what is the third most popular bug? Or we can also say the least popular bug. That's right, it is spider. It's okay, spider. I still like you. Okay, that is all the time today we have for data. Oh, hi everybody! Today I'm going to talk to you about probability. Probably! No, not probably. Probability. Probability. Actually, you say it like this. Probability. Probability. Yay, you got it. Okay, so probability is kind of like thinking about if something will happen or won't happen or will maybe happen. For example, tomorrow I will eat dinner. I know that this is true because I eat dinner every day. And if we know that something will happen, we can also say that it is certain. Certain! Let's say it together. Certain! Yes, one more time. Certain! But I wonder what I will eat for dinner. What about rocks? I said rocks! Do you think that I will eat rocks for dinner? No, I won't eat rocks for dinner. I know this because rocks are hard and they do not taste good and they could be very dangerous to eat. So I know that I definitely won't eat rocks. And if we know that something won't happen, we can also say that it is impossible. Impossible! Let's say it together. Impossible! Yes, one more time. Impossible! So, if I'm not going to eat rocks for dinner, I wonder if I will eat a plate of spaghetti. You know, I have had spaghetti before for dinner, and I like to eat spaghetti, so I think that maybe I could eat spaghetti for dinner. And if we know that something will maybe happen, we can also say that it is possible. Possible! Yeah, let's say it again. Possible! Yeah, one more time. Possible! Okay, let's take a break. I think it is a good time to juggle! Okay, that's enough. So, I am now going to tell you some things that could happen after dinner. And I want you to tell me if you think that it is certain that it will happen, or if it is possible that it could maybe happen, or if it is impossible, which means it won't happen. Oh, and by the way, there are also many other words we can use when thinking about probability. For example, likely and unlikely and many others. But today, I want to practice mostly the words certain, possible, and impossible. Okay, ready? Situation number 1. After dinner, I will fall asleep. Do you think that this is certain, possible, or impossible? Well, I fall asleep every night, so I think that this is something that is certain! Situation number 2. After dinner, I will fly to the moon and meet a dwarf named Betty. Do you think that this is certain, possible, or impossible? Well, I've never been to the moon before, and I don't have a rocket ship, and I don't think dwarves live on the moon. So I think that this is something that is impossible! Situation number 3. After dinner, I will read a book. Do you think that this is certain, possible, or impossible? Well, I sometimes read a book before I go to bed, so I think that this is something that is possible! Okay, I now have some probability situations for you. But first, let's take another break and juggle! Okay, that's enough! As I was saying, now I am going to say some things about what you could do after your dinner. And you can tell me whether they're certain, possible, or impossible. 1. After dinner, you will have dessert. 2. After dinner, a unicorn will carry you to bed. 3. After dinner, you will brush your teeth. 4. After dinner, you will dream about unicorns. Okay, great answers, everybody. And one thing I know for certain is that right now, it is time to juggle! Okay, that's enough. Okay, that is all the time today we have for probability. Probability! Oh, hi, everybody! Today, I'm going to talk to you about math and feelings and maybe even fish tanks. I really like fish tanks. Okay, everybody knows that math is just about numbers, right? Actually, nope. Math is about so much more than numbers. Math is about many things, like counting plates of spaghetti, patterns, sorting shapes, adding donuts, directions, subtracting donuts, tally marks, and so many other things. And did I say donuts? And just like there are many different things to learn in math, there are also many different ways to learn math. And no, I'm serious. For example, do you know how to count to 5? Yes, of course you do. Let's count to 5 together. Are you ready? Go. 1, 2, 3, 4, 5. Yay, good job. So, we just counted to 5 out loud with our voices. But there are other ways to count to 5 too. For example, when counting to 5, Apple likes to look at the numbers. 1, 2, 3, 4, 5. Orange likes to write the numbers. 1, 2, 3, 4, 5. Ladybug likes to see the words of the numbers. 1, 2, 3, 4, 5. Banana likes to use 5 squares. 1, 2, 3, 4, 5. Salamander likes to count salamanders. 1, 2, 3. Oh, I think that is too many salamanders for 3. Yeah, that's better, salamander. 4, 5. My brothers and sisters like to count out loud and together with each other.
1, 2, 3, 4, 5.
A sloth likes to count quietly by itself inside its head. 1, 2, 3, 4, 5. A scratch garden likes to count with a dog, in a rocket ship, and with music.
1, 2, 3, 4, 5.
Wow! Look at all the different ways to count to 5. There are so many different ways. And guess what? All of these different ways are great ways to count to 5. And they are all the right way to count to 5. Have you ever thought about which is the best way for you to count to 5? A fish tank! Sometimes I like to take a deep breath and watch the fishes, just to think. Which way is the best way for you to count to 5? And why don't you look around you? Are there other people near you? I wonder what way they like to count to 5. Okay, that's enough. And now, I have another question. Have you ever thought about how you feel when you are counting and doing math? Maybe sometimes you love numbers and are happy when you are doing math. And maybe sometimes you are sad or frustrated if you don't understand math. But guess what? It is okay to be happy or sad or frustrated. And if you can try and understand how you feel and talk about how you feel, that is great.
Excuse me. Sometimes I don't like doing math because I get nervous if I have to answer questions in front of everybody.
Oh, thank you for telling me that. That is totally normal. Later, we can talk about ways to maybe help you when you are feeling nervous.
Also, can I go to the bathroom?
No, you may not. Okay. I also want to say that learning math can take a long time. It is okay if you don't understand something right away. It's just like when you were little. You couldn't talk with words right away. First, you just made sounds that sounded like a goo goo gaga goo. And then you slowly learned the names of things and how to pronounce the things. And you practiced many, many times. And now you can talk and say a lot of words. And even hard words like perpendicular. There are probably many other things that you can do now that you probably had to try and try and try in order to do the right way. Can you think of any? Maybe let's think together. A fish tank! Sometimes I like to take a deep breath and watch the fishes and think. What are some things that you can do now that you couldn't do before? Maybe tying your shoes? Or eating food with a fork? What else? Okay, that's enough. And I have another question. Do you think it's okay to make mistakes? Actually, yep. Mistakes can be good because it usually means that you are learning and trying to learn. Yay! I have another question. Do you think it's okay to ask questions? Actually, yep. Asking good questions can help you to learn too. Especially if you raise your hand and speak in a nice, clear voice. And, oh, yes?
Is this a good example of how to ask a question properly?
Yes, it is. Okay, that is all the time we have today for talking about feelings and math.